Hello! In this clip, we'll get familiar with the vectorization operator. It's located in the Matrices and Tables tab under Vector Matrix Operators, right at the very bottom of it. How does it work? In the first example, we will use matrices. You can use the vectorization operator when you want to force an element-by-element operation. To illustrate this point, we define a simple 2x2 matrix, insert it from this panel, and fill in some simple values that we can easily verify them soon. In general, you're not allowed to use a matrix as an argument to the square root or sinus. Since we can't call these functions as a whole, we will call them on each element of the matrix. From the Math tab, in Operators, we will insert the square root operator. We type m and press equal. An error message appears mentioning that this value must be a vector, and the same would happen in the case of sinus. As mentioned, this message appears because matrices can't be handled directly, so a vectorization operator is needed. Let's add it. We select this and we click the vectorization operator. When we click in the worksheet, the result will be displayed. Let's do the same for sinus of m. Here it is. The next example is one that we can apply in the real-world calculations in engineering. We need to define first a vector of force. From the same panel, we give it some values, and we also give a proper unit, in this case pound force. This is automatically being recognized as a unit. We also need to define a vector of distance of the same size. We fill in some values and give the unit of inches. Now we calculate torque, which will be force multiplied by distance. When we evaluate torque, this performs a standard vector multiplication, and that's not what we want. So further, we calculate the vector of torque values. We do an element-by-element calculation for all entries in the force and distance vectors. Torque V will be under the following form. We insert the vectorization operator and force multiplied by distance. And now when we evaluate torque V, we are going to be able to see the proper result. We can overwrite these units in order to be able to see them better, to verify that 250 times 2.5 is 625. Now, torque V uses the vectorized product and returns a vector of the same size as the vectors of force and distance, in which each element contains the product of the paired elements of force and distance.